Dear students, in the present class we shall discuss about the question number 21. 3-hydroxybutanol is formed when X reacts with Y in dilute Z solution. What are X, Y and Z? See, 3-hydroxybutanol. Let's write the compound. 3-hydroxybutanol is nothing but butanol. Okay, butanol. Al, so it is an aldehyde. 3-hydroxy is this. Okay, position 1, 2, 3. So this is 3-hydroxybutanol. So in the initial stage, you have to write the product. Okay, this is the skeletal structure and fill with the number of hydrogens required. Okay, like this. So this is the 3-hydroxybutanol, and this is beta-hydroxyaldehyde. This is called aldol. So they are asking about the aldol. When the aldol will be formed, when the carbonyl compound with the alpha hydrogen is treated with dilute NaOH or dilute alkali, will give this aldol. Okay, and here see the hydroxyl part, okay, and the aldehyde part, both are having the two carbon atoms. Okay, this part is different, this part is different. Okay, now when you take out that, okay, compound CH3 C double bond OH, this is acetaldehyde. Okay, the common name is acetaldehyde and the IUPAC name is ethanol containing alpha hydrogen. Similarly, take one more CH3CH4. Okay, and this is also an acetaldehyde when treated with the dilute NaOH. Okay, see, when hydrogen from this group is transferred, you will get a hydroxyl group at this position. This will be reduced to the CH2. So this is the compound. Okay, what are the suitable options here? Okay, take the X. This is X, this is Y, this is Z. So X, Y, Z are acetaldehyde and NaOH. So therefore the option 4 is the correct answer. Option 4 is correct answer. Okay, where X is acetaldehyde, Y is also acetaldehyde, Z is dilute NaOH. Okay, go for the question number 22. The most reactive compound towards formation of cyanohydrin and treatment with HCN followed by acidification. Say the carbonyl compounds when treated with HCN, here the nucleophilic addition reaction will take place. Which of the compounds will readily undergo the nucleophilic addition? The simple aldehyde, then aliphatic aldehyde, then aromatic aldehyde. That is what we have discussed in the earlier class. And later the simple ketones, then that is aliphatic ketones, then the aromatic ketones. Here, which one will readily undergo? Okay, look at the option. The first option is benzaldehyde. First option is benzaldehyde. This is an aldehyde. The second one is para-nitrobenzaldehyde. The third one is phenyl acetaldehyde. Fourth is para-hydroxybenzaldehyde. Okay, here I am going to show you the structures of this. One is benzaldehyde. Okay, option 1 is benzaldehyde, 2 is para-nitrobenzaldehyde. The third one is phenyl acetaldehyde. Okay, phenyl. Take this C6H5 ring. Phenyl is acetaldehyde. So this will be CH2, CH4. 2-phenyl acetaldehyde is possible. Okay, then fourth one is para-hydroxybenzaldehyde. Okay, out of this, the simple open or aliphatic aldehyde is this. Okay, but here this is electron donating group. It reduces the polarity, and out of the benzaldehyde, the hydroxy benzaldehyde. This will readily undergo, and later, okay, here out of all these, okay, firstly here this one will undergo due to the presence of electron withdrawing group. Okay, when you write the order of the reactivity, option 2, that is para-nitrobenzaldehyde, then compound 3, okay, because it is an aliphatic aldehyde, then the simple aromatic aldehyde 1, then the 4th. Okay, due to the presence of electron withdrawing group, it increases the polarity of the CHO, and this readily undergoes the reaction with the HCN. Okay, and later this one will be, and out of this option 1 and 4, this one will readily undergo. Here OH is electron donating group, it still reduces the polarity. Okay, this is all based on the polarity. Polarity is more in this order and the reactivity also more, therefore here option 2 is the correct answer. Okay, then go for the 23rd. Skiff's reagent is, okay, option 3 is the correct answer, that is rosanilin hydrochloride. It is a Skiff's reagent. Keep in mind that this is a direct question. Rosanilin hydrochloride is the Skiff's reagent. Okay, go for the question number 24. Which of the following is a method of converting a unsaturated ketone into unsaturated hydrocarbon? This is Wolff-Kishner reduction. In the Wolff-Kishner reduction, the unsaturation will not be disturbed. Okay, but in case of Clemmensen reduction, the unsaturation will be disturbed. Okay, keep in mind that Wolff-Kishner reduction doesn't disturb the unsaturation. Okay, the option 4 is correct answer. Go for the question number 25. Which of the following aldehydes can give Cannizzaro reaction with base? Cannizzaro reaction where the carbonyl compounds must not have the alpha hydrogen. Okay, take question number 25. We are talking about Cannizzaro reaction. The aldehydes or ketones with no alpha hydrogen will undergo this. Okay, go for the question number option 1. Option 1 where there is alpha hydrogen CH3, CH2, CHO. Here we got alpha hydrogen, it cannot undergo the Cannizzaro reaction. Go for the option 2, that is CH3, CH2, CH, CH3, CHO. Here this is the alpha carbon having alpha hydrogen, therefore cannot undergo the Cannizzaro reaction. Come to the option 3, we have CH3, CH, double bond, CH, CHO. This alpha hydrogen is there, therefore it cannot undergo the Cannizzaro reaction. Come to the option 4, that is CH3, 3 times present on the single carbon. This is a tertiary one. Okay, tertiary carbon is present, CH2. Okay, here this is the alpha carbon carrying no hydrogen, so therefore no alpha hydrogen aldehyde readily undergo the Cannizzaro reaction. So therefore option 4 is the correct answer. Now come to the question number 26. Okay, here a mixture of benzaldehyde. Come to the question number 6. Come to the question number 6. A mixture of benzaldehyde and formaldehyde on heating with aqueous NaOH solution gives. We have benzaldehyde here. Okay, and formaldehyde. HCHO on heating with aqueous NaOH. See, both the compounds are not containing alpha hydrogens. No alpha hydrogen, no alpha hydrogen. These will undergo Cannizzaro reaction. These will undergo Cannizzaro reaction. Okay. Here, which one will undergo alcohol formation and which one will undergo the carboxylic acid formation. Always the formaldehyde undergo the carboxylic acid formation. Therefore, we get HCOONA. And in the Cannizzaro reaction, disproportionation takes place. Means the formation of an acid, okay, and the formation of an alcohol will take place. Which one will undergo the alcohol formation? The benzaldehyde. It will give the corresponding alcohol, that is benzyl alcohol. That is benzyl alcohol. Okay, like this CH2OH. So what is the name of this compound? Benzyl alcohol. Okay. Now, what are the products? Okay, benzyl alcohol and sodium formate. What is this compound? Sodium formate. Okay, sodium formate. So now choose the correct option. So option 1 is the correct answer. Option 1 is the correct answer. Okay. So in this case, there is a Cannizzaro reaction is taking place. The products will be an alcohol and the salt of carboxylic acid. Okay. Go for the question number 7. Okay. In this, chemical reduction of ketone is carried out in presence of zinc amalgam and concentrated HCl. Okay. In Chemanson's reduction, we use zinc amalgam in the presence of HCl. So choose the correct option. That is option 4. Okay. Yes, option 4 is the right answer. Option 4 is the right answer. Okay. Now come to the question number 8. Okay. Identify the product Y in the sequence. Let us see the sequence. CH3, CHO plus CH3, MgI. When this is treated in the presence of an ether as a solvent. See, this is a carbonyl compound. This is the Grignard reagent. So nucleophilic addition reaction will take place like this. CH3 will join this. Okay. So you get CH3, CH, CH3, OMgI. OMgI. When it is hydrolyzed, we will get the propan-2-OL as the product. What is this? Propan-2-OL. Propan-2-OL. So choose the correct answer. This is the CH3 twice. We can write this as CH3 twice CHOH. So choose the correct option. That is option 3. Option 3 is the correct answer. Okay. These are very simple. We have already discussed in the alcohols chapter and in aldehydes, that is previous CET class also. Okay. The addition of Grignard reagent to the carbonyl compound in the presence of an ether gives alcohol. Okay. And what type of alcohols we get, that is dependent on the type of the carbonyl compound and the methyl group present in the Grignard reagent. Okay. Yes. Go for the next question. That is question number 9. Aldol condensation will not be observed. See, for the aldol condensation, what is the necessary condition? The carbonyl compound must have alpha hydrogen. Okay. The compound with alpha hydrogen, the carbonyl compound with the alpha hydrogen will undergo aldol condensation. Now, what is the question? Aldol condensation will not be observed in chloral. What is chloral? CCl3 CHO. Here, this is the alpha carbon atom not having the hydrogen. So, no alpha hydrogen. It cannot undergo aldol reaction. Okay. So here, this is the correct answer. Question is, which of the following compound cannot undergo aldol condensation? Therefore, chloral cannot undergo. And look at the option 2. Okay, that is phenyl acetaldehyde. It undergoes because of presence of alpha hydrogen. Hexanol, it undergoes because it is having alpha hydrogen. Ethanol, look at that spelling Al. It is nothing but acetaldehyde. It has alpha hydrogen and undergo the aldol condensation. Okay. Now go for the question number 10. Which of the following is incorrect? Which of the following is incorrect? FeCl3 is used in detection of phenols. Yes. When phenol is treated with FeCl3, gives a precipitate. Okay. Phenols can be detected using FeCl3, that is ferric chloride. Okay. Filling solution is used in the detection of glucose. Yes, all the monosaccharides are called reducing sugars, which reduces the fillings and tolerance reagent. Okay. Now glucose reduces fillings reagent. Okay. Tolerance reagent is used in detection of unsaturation. See, the unsaturation can be identified by the Bayer's reagent or the bromine. Okay. Here, the tolerance reagent cannot be used to detect the unsaturation. This is the incorrect statement. Therefore, correct option is this. Okay. Option 3 is correct. Okay. Unsaturation can be determined by the Bayer's reagent or bromine. Keep in mind that. Okay. But tolerance reagent cannot be used for that purpose. Okay. Yes. Go for the next one. The question number 11 is the reagent used for separation of acetaldehyde and acetophenone is, as we have already discussed, the best reagent is sodium hydrogen sulfide. Okay. This can be used to differentiate the aromatic ketone and the ketone, simple aliphatic ketones and aldehydes. This reacts with the acetaldehyde, okay, acetaldehyde, but cannot react with the acetophenone. So that is why this is the best reagent. Okay. Yes. Remaining options, that is the option 2 is hydrazine, phenyl hydrazine, option 3 is hydroxylamine, and option 4 is this one, haloforum. Okay, haloforum test reagent, that is a sodium hypoiodide. So these three, option 2, 3, 4 cannot be used to distinguish these acetaldehyde and the acetophenone. Okay, so the best one is sodium hydrogen sulfide. This reacts with acetaldehyde to give a salt. This cannot be reacted with this one. Okay, therefore this is the best distinguishing reagent for these two. Okay. Now go for the question number 12. That is the reagent which can be used to distinguish acetophenone from benzophenone is, okay. Here look at the option 1, 2,4 dinitrophenyl hydrazine. The hydrogens will react with almost all types of the carbonyl compounds, that is aldehydes and ketones. Okay. Aqueous solution of NaHSO3. NaHSO3 cannot react with these two. See, option 1 reacts with both of these, option 2 cannot react with both of these. Okay, we don't have any advantage. Benedict's reagent. This is very similar to the Felling's reagent. Okay, Felling's reagent. So you know that Felling's reagent cannot react with the ketones. So therefore, Benedict's reagent also cannot react with the ketones. Okay, and go for the I2 and NaCO3. Here, haloform test will come out. Haloform test. Take the acetophenone. Okay. This is the acetophenone. It is a methyl ketone. It undergoes haloform test. benzophenone. It is not a methyl ketone. It is not a methyl ketone. That is why it cannot undergo haloform test. Okay. So mixture of Na2CO3 and iodine will give NaOI. Will give NaOI. Sodium oxyiodide or sodium hypoiodide. It is called. Okay. Acetophenone undergo this iodoform test because of presence of a methyl ketone, and benzophenone cannot undergo this test because it is not a methyl ketone. Okay. Now, so therefore option 4 is correct answer. Option 4 is correct answer. Okay. Yes. Now come to the question number 13. It is Cannizzaro reaction is not given by. See, you know that Cannizzaro reaction is given by the aldehydes or ketones with no alpha hydrogen. Cannizzaro reaction is given by the carbonyl compounds having no alpha hydrogen. Having no alpha hydrogen. And here we have to identify which option compound is not having alpha hydrogen. And here trimethyl acetaldehyde. Compound 1 is trimethyl acetaldehyde. See, this part is acetaldehyde and having a 3 methyl groups. So therefore it is a trimethyl acetaldehyde which is having no alpha hydrogen. It undergoes Cannizzaro reaction. Okay, but what they have asked is not given by. So here we have to identify the compound with alpha hydrogen. Okay, so take out the acetaldehyde. Okay, here we have alpha hydrogen. Okay, it cannot undergo Cannizzaro reaction. It cannot undergo Cannizzaro reaction. Therefore, it is the right answer. Therefore, it is the right answer. Acetaldehyde is having the alpha hydrogen, therefore cannot undergo Cannizzaro reaction. Okay, and go for the benzaldehyde. Okay, option 3 is benzaldehyde. It is also having no alpha hydrogen. Okay, so it undergoes Cannizzaro reaction. Okay, and option 4 is formaldehyde. It is also having no alpha hydrogen. So it also undergoes Cannizzaro reaction. Here the question is, which of the following compounds are not giving the Cannizzaro reaction? That is the option 2 because it is having a alpha hydrogen. Okay. Yes. Go for the question number 14. That is, benzophenone can be converted into benzene. It's very simple. When this is treated with a fused alkali, it is treated with a fused alkali. For example, take the benzophenone. Take the benzophenone. This is a benzophenone. And treat with a fused alkali like KOH. Fused alkali like a KOH. What happens? When this is treated with a KOH, here the bond breaks. You will get COOK and the benzene. Here, OK, potassium oxide will be attached to this and H will be attached to this. Okay, so you will get a potassium benzoate. Okay, plus benzene. Okay, when this compound is further fused with KOH, what happens? You will get a benzene. You will get a benzene, and see this hydrogen joins here. This OK combines this with the carboxyl part to give CO2. Okay, or K2CO3. Finally, you will get a K2CO3. Okay, this is what COOK. This is what COOK. So here you will get a decarboxylation will take place. Okay, K2CO3 will be formed. Okay, when benzophenone is treated with the fused alkali, the final products are benzenes. So, therefore, the option 1 is correct answer. Now come to the question number 50. Reactivity towards nucleophilic addition reaction is. Yes, we have already discussed that the first compound is simple aldehyde, next is aliphatic aldehyde, then aromatic aldehyde, then the aliphatic ketones, then aromatic ketones. This is the order of the compounds for reactivity, that is undergoing the nucleophilic addition reaction. Okay, so here we have 4 compounds. HCHO, compound 2 is CH3CHO, the third compound is CH3COCH. In these 3 compounds, which one is simple aldehyde? This one readily undergo the nucleophilic addition reaction, followed by the compound 2 and followed by the compound 3. Since it is a ketone, it slowly undergo the nucleophilic addition reaction. Therefore, option 3 is the right answer. Option 3 is the right answer. Okay. Yes. Go for the question number 16. The reagent with which both aldehydes and ketones react is. Usually, we have to make use of the nucleophilic addition reaction in which these compounds will undergo. Take the first option, Fleming's solution. It is used to identify only the aliphatic aldehydes, but not the ketones. Okay. Grignard reagent. With this Grignard reagent, the both aldehydes and ketones readily undergo the reaction. So, the reagent with which both aldehydes and ketones react is. Obviously, the answer is Grignard reagent. Therefore, option 2 is correct answer. Why not the option 3? Option 3 is Skiff's reagent. Okay, and option 4 is Collins reagent. Where option 4 with the Collins reagent we can identify only the aldehydes. Okay, but not the ketones. Okay. Yes, and not all the carbonyl compounds are forming the Skiff's reagent. Okay, especially the ketones. Okay, because of its low reactivity. Okay. Yes. Come to the question number 17. So what is that? Which of the following compounds gives Kanizawa reaction? See, already it is discussed one. In the Kanizawa reaction, the carbonyl compounds carrying no alpha hydrogen undergo. Okay, the carbonyl compounds with no alpha hydrogen undergo Kanizawa reaction. We need to identify the carbonyl compound with no alpha hydrogen. Okay, option 1 is CH3, CH2, CH4. This is the alpha carbon having alpha hydrogen. So it cannot undergo the Kanizawa reaction. Okay. And the second one is HCHO. There is no alpha carbon, no alpha hydrogen. Therefore, it undergo Kanizawa reaction. Therefore, option 2 is the right answer. Okay. And why not the option 3? Option 3 is CH3, CH, CH3, CHO. This is the alpha and carrying alpha hydrogen. Therefore, it cannot show the Kanizawa reaction. Okay. Come to the option 4. This is acetaldehyde. Okay. Here we have alpha hydrogen. Therefore, it cannot show the Kanizawa reaction. Therefore, option 2 is the right answer. Okay. Come to the question number 18. When acetaldehyde is heated with a Fleming's solution, it gives a PPT of. So in the Fleming's test, the PPT of Cu2O will be formed. This is called as cuprous oxide. Okay, red PPT is red or brown PPT is. Okay. So in the Fleming's test, what is the observation? Colorless to red brown precipitate due to the formation of cuprous oxide. Okay. Now go for the question number 19. Okay. Which of the following reagents involve nucleophilic addition followed by elimination of water on reaction with carbonyl compound? Means they are asking about the nucleophilic addition mechanism. The option 1 is hydrogen in presence of feebly acidic solution. When the carbonyl compound is treated with a hydrogen NH2, it undergoes nucleophilic addition, okay, to give this OH, then NH2, and on heating, what happens? It will be dehydrated, okay, to double bond and NH2. So up to here, this is nucleophilic addition. Therefore, option 1 is right answer. Okay. Why not the option 2? When the carbonyl compound is treated with a lithium aluminum hydride, we will get a alcohol. Okay, this cannot involve the addition reaction. Okay. And here when option 2 we use, when the carbonyl compound is treated with lithium aluminum hydride, it undergoes nucleophilic addition but not elimination reaction. Okay, elimination of water is not possible. Option 3, it also undergo addition reaction but not elimination of water. When you go for option 4 also, it also undergoes the nucleophilic addition but not elimination of water. Here you can see the elimination of water, that is called dehydration. So therefore option 1 is the right answer. Okay, and come to the question number 20. Okay, which of the following compounds will most readily be dehydrated to alkene under acidic condition? Okay, come to the compound 1. This is 4-hydroxy pentan 2,1. Pentan, take 5 carbon atoms. Pentan 2,1 is this. Okay, if this is 1, 2, 3, 4, 5, and 4-hydroxy. This is 4-hydroxy. Okay. See, this is a skeletal structure and filled with the hydrogen CH3, CH, CH2. Okay, this is already satisfied with the tetravalence, and this is C. Here, what happens? Alpha hydrogens are acidic because these are adjacent to the carbonyl carbon. This hydrogen will come out and OH minus will come out. Elimination will take place. Okay, and it gives CH3, CH, double bond CH, C double bond O, CH3. Okay, since it is a ketone, ketones or aldehydes readily undergo the condensation. Okay, so therefore option 1 is the right answer. Option 1 is the right answer. I repeat. Which of the following compounds will most readily be dehydrated to give alkene? So this is what alkene is formed in these under acidic conditions when treated with an acid or heated. Okay, H2O comes out. Okay, so and the remaining compounds are not so acidic. Okay, so this is all about the solving MCQs on the aldehydes and ketones. From the next class onwards, we will discuss about the carboxylic acids. So here in the material we gave to you, covering more number of MCQs, you try to solve those MCQs. Okay, yes, thank you.